when you take a look at your notes, and I am on, still in 7.4, but now I'm on part 3. Do you remember doing this earlier in the year? Everybody else. Okay? Does anyone remember doing this? How do you think we'll start? We're going to sketch it. That's our job. We're going to sketch it and label asymptotes, holes, and intercepts. Who remembers how to start?
You gotta find the vertical asymptote and horizontal asymptote.
Okay, exactly. And what do we have to do to get that ball rolling?
You gotta take the bottom part of the equation and then you gotta equal it to 0 and then you should factor that out.
Okay, so actually I can do that. I can actually just factor it the way it is. So x plus 2, x minus 2, and x plus 3, x minus 3. Now, sometimes when I do that, those are both the difference of squares. Sometimes when I do that, I can cancel, right? And canceling means that we will have a hole. Since nothing cancels, this problem isn't going to have any holes. But it does have 2 vertical asymptotes, because vertical asymptotes come from the denominator, what x cannot be. So in this problem, x cannot be -3 or +3. So we have 2 vertical asymptotes. If this is like a foreign language to you, because you've forgotten everything, you need to write down vertical asymptotes are cannot be's. What can x not be? It cannot be -3 and it cannot be +3. Vertical asymptotes come from your denominator. All right, guys, I need you, I know we had a long, hard day, but I need you to think about this, because we're not going to spend a ton of time on it. We've already been through it once, back in the day. All right, now, Jacob mentioned a horizontal asymptote. Horizontal asymptotes come from boxing in your highest power. That better look familiar. We spent a lot of time on that. You have an x squared over an x squared. That's going to reduce to 1. So your horizontal asymptote is at 1. All right, we're going to talk about each one of these things more as we go through, but let's try to keep up here now. So we've agreed, no holes. Why are there no holes? Nothing canceled. All right, you got to cancel to get a hole. No, nothing cancels. Now we got all our asymptotes covered. Now, the only other thing you need to graph this, hopefully, are the intercepts. The intercepts, remember, are the points where we cross an axis. Like this might be a y-intercept, and this might be an x-intercept, right? It's where we cross the axis. How do we find intercepts? They're points on the curve. How do we find them?
Equal
Let something be 0. So you're going to find your y-intercepts by letting x be 0, and you're going to find your x-intercepts by letting y be 0, right? So if you're going to let x be 0, you can plug it in the factors, or you can plug it in the original problem. It's probably easier just to plug it in the original problem, because if you put a 0 in there, then y is just going to be 4/9. So your y-intercept is 0, 4/9. Your intercepts are points. Set up a t-chart. One way to do it is to set up a t-chart, put a 0 in for x and a 0 in for y. That's going to give you your intercepts. Now, if I let y be 0, I'm just going to put a 0 here for y. I'm going to multiply this over, and it's going to disappear, right? Would you agree the denominator is going to disappear because I'm multiplying it over here to the 0? So basically now I'm left with this equation, which tells me x is going to be what? Either -2 or +2. Those are your x-intercepts. When you have factors, you just simply set each factor equal to 0. Denominator disappeared because I multiplied it out. That will always happen because you're going to be multiplying it by 0. Now, in terms of like special stuff that you were told to find, that's it. Can you visualize this? What do you think this looks like? Yeah, in here, it looks pretty obvious. I've got some kind of a parabola in here. Just by connecting the dots. But there's graph out here too. Anybody want to hazard a guess what it looks like out here? Yes, exactly. That and that. Remember those kind of hyperbola type shapes from before? Some of you might be saying, well, Mrs. Ford, how did you know it was up there? Well, let's remember, you can always plot more points. Okay, so one option you have is to plot more points. But also remember that the curve is always going to approach its asymptotes. That's why we have asymptotes. That's what asymptotes do. The curve gets closer to them. So the only other thing that could look like would be this. That could be a possibility. How do I know that's not the possibility, though, for this one? What happens right here? And haven't I already figured out where it crosses the axis? It doesn't cross the axis anywhere other than the points I already figured out. So whatever you start freehanding can't cross the axis. So it can't look like that. All right? Now, let's try the next one and see if it comes back to you any easier than that one does. I think this was like chapter 2. Get all this. All right, so what do you think? We're now on problem B. What do you think we're going to do with problem B? Got to factor it all. So the top factors as +5 plus 1. Oops. No matter how old you get, guys, no matter what math class you take, you never get away from factoring. Got to be able to factor. What about the bottom? Take a 2 out. Very good. It is always going to be easier if you get rid of your GCF. So I'm going to get rid of my GCF. I'll take a 2 out, and that leaves me with x squared minus x minus 2. Now, does that factor? Keep the 2. Got to keep the 2. But does this factor? X minus 2 plus 1. Is that right? Okay, now what do we notice? There's going to be a hole because these are going to cancel. I'm going to go ahead and rewrite my problem. Rewrite my problem, what's left, and this is now going to be the problem that I graph. So I factored everything, canceled out what cancels, and then what's left, that's what I'm going to graph. Now, before I get too far into it, though, I do have a hole, as you indicated. And that hole is going to be a point, I mean, open dot in the picture, and it is going to have an x-coordinate of -1. If this hadn't canceled, wouldn't your asymptote be at -1? That's where your hole is going to be. So it's going to be at where x is -1. Then how will I find my y? Plug it in right here. Right here. So if I plug in -1, I'm going to get 4 on the top and 2 times -3 on the bottom. So that's going to be 4 over -6, which reduces to -2/3. All right, so for those of us that are foggy, every problem starts with factoring. If you can cancel something, you're going to have a hole, right? And you're going to know where the hole is because whatever factor canceled out, that's the x, that gives you the x value. And then, plug that into your new problem, that gives you the y value. pretend that this is what I started with, and I'm just going to graph stuff from here, okay? So what does this tell me? I got a vertical asymptote at 2. If we're foggy, we've made a note over to the side. Vertical asymptotes are cannot be's. Vertical asymptotes happen when the denominator is 0. Now, what about a horizontal asymptote? Well, look carefully at this problem now. If I multiplied it out, I would have 1x over 2x. Would you agree with that? So my horizontal asymptote is going to be at 1/2. Now, could I have told that from the original problem? Yes. So you can get your horizontal asymptote from the original problem also. So y equals 1/2. All right. Now we need our intercepts. So again, if you're all confused, set up a t-chart. Put a 0 for one point at x and a 0 for the other point at y, and figure them out. So if I put a 0 in for x, on the top I'm going to get 5. I'm going to erase some of this here. On the top I'm going to get 5, and on the bottom I'm going to get 2 times -2 if I put a 0 in. So that's -5/4. So my y-intercept is -5/4. Now, x-intercept, I need to let y be 0. So I'm just going to put a 0 right here. Now, to solve that, I'm going to clear the fraction. So when I multiply this over here, it's going to go away, right? So what value of x is going to give us -5?
You were going to explain before, right after you read your thesis statement. You will explain to the rest of
Now, you have everything you were told to put in the graph. You can always plot new points, kids, always plot new points. But, do we have enough to draw this picture? I think we do. Certainly, can we? And then you probably remember from before, if you've got a chunk of this down here in this corner, you're going to have another chunk up here. You got to remember that shape, you guys. We had 1 billion of those. Maybe not quite 1 billion, but we had a lot. Okay? All right, one more. Let's see how you do it this way. Well, actually, this problem is a lot simpler because we have no factoring, correct? We have nothing to factor. And nothing cancels. So, no holes. We can just start jumping in and putting our stuff in here. So here we go. All right, so tell me what we have. All that important stuff. There's no holes. What about asymptotes? Vertical asymptote is -1/8. That's exactly right. So we're going to have some fractions in here. So vertical asymptote at -1/8. The denominator of a fraction can never be 0. So 8x plus 1 cannot equal 0, which means x cannot equal -1/8, and vertical asymptotes are cannot equals. That's how you get vertical asymptote. All right, how about a horizontal horizontal asymptote? Y equals 7/8. Yep, y equals 7/8 right from here. So here is y equals 7/8. Now to find your intercepts, let's not make this complicated. If we let x be 0, it looks like y is going to be -2. So that's my y-intercept. So what is your x-intercept? 2/7. Based on that, remember, you can always plot more points if you want. Make up some numbers and plot. But usually, once you get all that, you know what this looks like. You know what this looks like? These are connected like this. Remember, we got to approach our asymptotes. And if you put a chunk down here, then the next other chunk is going to be up here. And that's it. Section. Does anybody have a question about one of these problems? I know I erased the other two, but you can look at them anyway. Do you have it figured out how you put in the vertical asymptotes and the horizontal asymptotes, your intercepts and your holes? You got that under control? Now we're going to do what are called a couple of linear programming problems. And linear, actually got 3 of them, I guess. Linear programming problems look massive. I mean, that's the problem, it's the whole page. But if you approach them one step at a time, they're not too bad. Linear programming is used all the time in like business applications, cost, profit, those kinds of applications. So those of you that are intending to, study business type courses in college, you'll have to do some linear programming. All right, these are very simple. Yours might be a little harder, but here's what you're going to have. First of all, I will set up for you your chart. I'm not going to fill it in for you. I'm going to label it for you. Like this one is nitrogen and phosphorus and cost, and this is A, B, and total. So I will have this set up for you. Your test question will look just like this. And then I'll have these blanks here. And these blanks, and there can be more or less than you need. Those fill in how many you need. These are called the constraints. We're going to build those. You'll see how easy it is. It's simple. You did this last year. Do you remember it? Sort of? Familiar? You may have been virtual when you did it. I don't know. And then you'll have another blank. I'll put it up here. And it'll be for your whatever you're going to minimize or maximize. So linear programming problems are always minimizing something or maximizing something. So think about it. If you're in business, don't you want to maximize your profit? You'll do a problem like this to do that. If you're in business, don't you want to minimize your cost? Yep, this will do that. This is going to maximize or minimize. All right, and then you're going to have to graph it. And when I set up the grid, I did my best. This is quadrant 1 only. You're not drawing like you just did, where you're drawing it all over. You're only graphing in quadrant 1. Can explain or take a guess why you think we're only going to be graphing in quadrant 1 for these problems. Yeah, if we're buying, what are we doing here? We're buying bags of fertilizer. Can you buy negative bags of fertilizer? No. And in fact, in most things in business, you're building car parts. You're, I don't know, fishing for different kinds of fish. Negatives aren't part of that, usually. So our graphs are going to be set up in quadrant 1, which means automatically that 2 of your constraints are x is positive and y is positive. Given, automatic. Don't have to search for it, that's given. Okay? Now, let's fill in the chart. What do you think? Can you fill in any of the chart values here? The purpose of the chart is just to organize so that you can write the equations that are going to go here. So tell me what you think about the numbers in the chart. They need at least 180 units of nitrogen and 90 units of phosphorus. Where does that go? Nitrogen total has to be 180, and phosphorus total has to be 90. Would everybody agree with that? We have 2 brands of fruit. Brand A costs $10 a bag. So brand A cost is $10 a bag. And brand A has 4 units of nitrogen and 1 unit of phosphorus. So if we think of this in terms of a matrix, I know it's a chart, it's not really a matrix, but isn't this the A column? This tells me everything about A. Well, what's the B column going to look like then? $5 is the cost, and 1 unit of each nutrient. Now, this problem is a little bit tricky because it actually gives me a maximum cost when my job is to minimize cost. So I really don't even want to put an 800 in here. I can in parentheses, I guess, to remind me. But my job in this problem is to minimize, well, I'll just circle minimize. I need to minimize the cost so this is what I'm going to be minimizing. 10 A's plus 5 B's. Isn't that what it's going to cost me when I go into this place to buy the fertilizer? $10 for every A and $5 for every B? Now, whatever that is, it can't add up to more than 800, but I don't want it to be 800. I want to minimize it. So I'm really not going to use that 800 until I'm done with the problem. I cannot have an answer more than $800. All right? So now I'm going to write my other constraints, and this is so easy. Never do your whatever you're minimizing or maximizing. So whatever you're minimizing or maximizing is its own separate thing. But the rest of it are your constraints. So what equation do you see here in the nitrogen row? What equation comes at you from that? Okay, and you're using X's and Y's, and I'm using A's and B's, so let me be consistent. And I'll use X's and Y's instead of A's and B's since I did down here. So yep, you're exactly right. 4X plus Y has to be, now watch your sign, they need at least 180 units. So 4X plus Y will be greater than or equal to 180. Now, let's graph that. 180 is a pretty big number, so maybe we should let our scale be tens. And here's the best way to graph this. Okay, so my scales are going to be 10s. Each hash for me is going to be 10. The best way to graph this is to use the intercepts. So if we let x be 0, if we just take x out of the equation, y will be 180. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then, if we cover up y, what is that? 45, x would be 45. Everybody see what I'm doing?
Yeah.
So, 1, 2, 3, 4, 5, 45 right there. Oops, it's backwards. 45, 0. Now, let's connect those with a nice straight line. That's supposed to be a straight line. And where would it be shaded? Would the triangular region be shaded, or would the out part here be shaded? Out part, because it's a greater than. And we knew it was greater than because the words in the problem say at least 180. At least 180 means greater than or equal to. All right, so I'm going to shade out here. All right, so all that's shaded so far. Okay, let's get another constraint. What does this equation say? What does the phosphorus equation say? So I'm going to graph that one the same way. I'll use a purple marker for that one. And if I cover up x, y is 90. 1, 2, 3, 4, 5, 6, 7, 8, 90. And if I cover up y, so is x. So that was 50, 60, 70, 80. Now I'll connect those two with a nice straight line. Everybody grasping how we're graphing these, how we're getting those points? Now where is that one shaded? Outside, yep, above it, yep. So now, all right, so now I got all this purple. Remember, we're only in quadrant 1. So are you starting to see a region of the picture that is red and purple? All right, let's put our cost one in there because it's going to kind of cap it. I'll do it in green. I don't like writing a constraint for that, but I'm going to go ahead. Normally you don't, but I got the information. So 10x plus 5y has to be what? Less than or equal to 100? Or 800, I mean. I'll do that one in green. So if I cover up x, what's 800 divided by 5? 1, is that 160?
I think so.
100 divided by 5. Yep, 160. So that was y. So 160 is right here. And then I'm going to let y be 0. So x will be 80. So that's right here. I'm going to go ahead and draw that one in. You have it so, yours is picture is going to look so much better than mine. There we go. Is that okay with everybody? Where is that one shaded? Underneath. So let's try, it really messes up my board with too much shading. So let's try to see what's going on. We need to be above the red, above the purple, and below the green. I am thinking, see if you agree, that we are somewhere in this triangle. Does that make sense to everybody? The answer to the question is going to be one of these big black dots. So one of those dots, remember these are points with an X and a Y. So that's going to tell me how many A's I need and how many B's I need. One of these points is. All right, so here's the great mystery. How do I figure out those points? Any thoughts on that? You know. We talked about it in 7.1. And you talked about it when you were freshmen, and when you were sophomores, and when you were juniors. This point right here, I'll just start with this one, is the intersection of my purple line and my green line and I want to know where they cross. How do I figure out where purple and green cross? What do I have to do? Substitute, eliminate, Kramer's rule, inverse method, type it in on your calculator, whatever. That's how you figure it out. So I'm going to go ahead. This one looks like I can eliminate pretty easily. So I'll just multiply by -5. I always eliminate when I have a choice. So x is 70. But you could substitute or do, you know, if you want to mess around with a matrix, you could RREF it. And once I know that x is 70, then I can go back and figure out that y is 20. So one of my vertices of my feasible region is 70, 20. This area is called your feasible region. Reed, is your hand up?
Why isn't that not even?
Well, I got to do all of them.
Oh.
I just randomly pick that one first, but I have to do them all. I can't figure out the answer until I check them all. So I just pick that one first. Now we'll come over here, and this one is the intersection of purple and red. So I'm going to do the same thing. Purple is x plus y equals 90, and red is 4x plus y equals 180. It's nice to use colors. You don't have to, but it helps here. It helps. So I've got red and purple coming together there. So I'll multiply through by a negative, and it looks like 3x equals 90, so x is 30. And if x is 30, then y has to be 60. Is that right? So there's another one. Okay, why don't you do the last one? This one is the intersection of green and red, my green and red. Why don't you work on that, and I'll work on that, and we'll see if we come up with the same thing. I got 10, 80.
Okay, so we're talking about in-text citation.
Anybody else? No? I could have made a mistake. 4x plus y equals 180, and 10x plus 5y equals 800. That's my red and my green. So I multiplied the top one by -5. And added. I think 10 is right. At least I'm not making a mistake. Oh, 80's wrong. put it in the wrong equation, so x is 10, yeah, if x is 10, then 40 plus y equals 180. Did you get 10 comma 140? Yeah, there we go. Yep. I put it in the wrong equation.
Copy the bold, please. Usually, the author's last name.
Okay, try not to be bored here, folks, because now we're getting to the exciting part. Now, we have to figure out which one of these will give us the lowest cost, because that's what we're trying to minimize. So we take each of these points now, and we find the cost for each of them. So if you buy 10 and 140, what will your cost be? Well, it's 10 times x plus 5 times y. So 10 times 10 plus 5 times 140. That's going to cost you exactly $800. Okay? Now, down here, 30 and 60. So 10 times 30 plus 5 times 60. That's going to cost you $600. And then 70 times 10 plus 20 times 5. That's going to cost you $800 again. So if you're this guy, farmer or whatever, and you are buying fertilizer, what are you going to advise this guy to do? You're his financial advisor. What are you going to tell him to do? Buy 30 bags of A and 60 bags of B, and your cost will be $600. Write a sentence that says that. He should buy, or I should buy, I don't care what pronoun you use, he should buy 30 A's and 60 B's for a cost of $600. This space in here, this triangle, is called the feasible region, and it is full of possible answers, so any point in there would be okay. The vertices, the big black points, will always give you the maximum and the minimum. The max and min will always come from there. So your minimum is $600, and your maximum is $800, and it's coming from either here or here. You could do it either way. All right? Well, that was exciting. Take a deep breath. We're going to do another one. Yes, quit whining. It's your cost. So 10 times your x and 5 times your y. That was the whole point of doing the problem. We were trying to find the minimum cost. All right, well, I'm getting my stuff set up here. Why don't you see what kind of luck you have filling in your chart? So we're now on problem B, and we're going to fill in the chart. See how far you can get while I erase. At least the hammering stopped. Okay, I'm just reading through the problem, and the first number I see is 24. Where does that go? 24 is the total low grade. You okay with that? And then 6 is medium, and 30 is high. Everybody good with those three numbers, placement of those three? All right, factory A, here's factory A. He produces 8 tons of low grade, 1 ton of medium grade, and 2 tons of high grade. It costs $2,000 per day to operate. So this is all A information, so it's in the A column. And then D is 2, 1, 8, and 4,000. Have I organized every number in the problem into my chart now? I have. This one is blank. What would that represent? What does that position represent? That would be the total cost. And let's read the question. How many days should each factory operate to minimize cost? So we're going to minimize cost, and it's 2,000 plus, or 2,000 X, or 2,000 X's plus 4,000 Y's. This is not known to me. I don't have any idea what that is. Don't worry about it. If you don't have a number, don't worry about it. It's usually blank, because that's what the answer is. That's what I'm trying to figure out. Okay, so what are my constraints? 8x plus 2y. Now be careful, is it going to be a greater than or a less than? What do you think? It doesn't really say specifically in the problem, but what would be your gut feeling? Yeah, if they need to produce 24, then doesn't that imply at least 24? So 8x plus 2y is greater than or equal to 24. What does this one say? X plus y is greater than or equal to 6. And what does this one say? 2x plus 8y is greater than or equal to 30. Now this one I can't write a constraint for because I don't have a number here. So I've already accounted for that. That's going to be what I minimize. But I do have 2 more constraints that are automatics. X and y are both positive. All right, any question about that? All right, well, how about you just start graphing now? Would you start graphing these? Now, with these size numbers, I don't think we have to change our scale. We'll just use ones. But go ahead and start graphing it. Remember that these are all greater thans, so you'll be shading above for all of them. So let's go ahead and get it sketched. Remember, we cover up one letter. And don't forget to label your points, because you're probably going to need some of them this time. That's a 3, a 6, and a 15. I think those are right, but they could be wrong because I did it in my head again, which is dangerous at my age. So everybody's here but Solar. All right, does this look at all like your picture? And since they are all shaded above, that means above the red or out here, above the green, above the purple, I think the overlap shaded area would be that. Would you agree this is what the overlapping shaded area is? So the answer to the question is going to be this point or this point, which I don't know, I'll have to figure it out. This one I'll have to figure out, or this one, which is 15, 0. So 2 of my points I know just from the graphing. The other 2 I'm going to have to figure out. Are you with me? Remember, the answer comes from taking these points and plugging them into the expression you're maxing or min. So I need to figure out these 2 points. So using my color scheme here, this one is the intersection of purple and red. And this one is the intersection of purple and green. Oops, I didn't label it, but that one's green. Everybody's still with me here at various stages of this? You know what you're doing? You're solving these systems using substitution, elimination, Kramer's rule, whatever you want to do. Last problem, we're almost done. I got 2, 4, and 3, 3. So now the very end of the problem, the very last thing you do is take each of these points and plug them into your cost expression. So if you take 2,000 times 0 and 4,000 times 12, this combination is going to cost you $48,000. $15 and 0 costs you $30,000. $2,000 times 2 plus 4,000 times 4 is $20,000. And then the last one, 3 and 3, would be $18,000, I think. I did that one in my head. That could have been a mistake. Everybody follow that step? Okay, then the answer is easy. We're minimizing cost. So if we're the financial advisors for this situation, we're going to say we need to operate plant A. Wasn't that a plant? factory. Yeah, we need to operate factory A for 3 days and factory B for 3 days, and it's gonna cost us $18,000 to do that. So let's operate A for 3 days and B for 3 days for a cost of $18,000. And that answers the question. How many days to fill the orders at minimum cost? The good news is we got one more to do, so we'll get one more chance at practicing.